All right, everybody, welcome to part 3 of the Reddit build. My name is Shadi, and if you are new here, this is part 3 of a multi-part series I am doing, so please check out part 1. It'll be somewhere available at the top of the screen. And I have created a Discord server for you guys to join and get direct access to me to ask questions about the project or really about anything. So please join that. I would love to see you in there. The link is in the description. All right, so last time we built a ton of UI components and we got authentication completely done. And we are now ready to start actually creating communities and posts within those communities, which is super exciting. We're going to start working with Firestore very heavily and we're going to learn a ton. All right, so the first thing we're going to do is inside of our create community modal, we're going to create the function that's actually going to be responsible for contacting our Firestore database and actually creating the community. So let's create that now. We're going to call it handle create community. And this function is going to need to be asynchronous because we are going to be communicating with our database, which are asynchronous operations. So just use the async keyword there. So there are a few things we're going to do in this function. The first thing we're going to do is validate the community name. We're going to make sure that this name is valid, that it is between 3 and 21 characters, which is a requirement of Reddit, and that the community name is not already taken by someone else, because on Reddit, community names are unique, so only one community with a specific name can exist. So we need to check for that. The second thing we're going to do is actually, if it is a valid community name, we will actually create the community document in Firestore. Perfect. Now, before we can actually communicate with our Firestore database, we do need to create it. So let's go back to our Firebase console, and all we need to do is just go to Cloud Firestore. You can access it from this giant card here, or you can access it from the Firestore database tab on the left here, and just go into that. And all we need to do is just click Create Database, and this modal is going to pop up asking you if you'd like it to be in production mode or test mode. And in production mode, this just says writes are not allowed. You have to write your own custom security rules for production, which we are going to do later. For now, we're going to use test mode, which is basically just going to allow read writes by anyone at any time, which is perfect for development. So let's click that. And then it's going to ask you to set a location. Just use whichever one appears for you first. I think it's a region based, so depending on where you are in the world, it'll give you the optimal one. So we can just click enable. And now it's just going to actually create those resources on the Google servers. All right, so perfect. Here is our empty database. On the left, we're basically just going to have a column of all our collection names. So communities, for example, is going to be a collection. Posts is going to be a collection. Comments is going to be a collection. And then when you click on one of those things and go inside of it, it'll show you all of the documents inside of that collection. And a document is basically just a JavaScript object inside of a collection. At the top here, there is a section called rules, and this is what we briefly saw in that modal. This basically just allows you to lock certain parts of your application and allow only certain users or user types to read or create certain documents or delete certain documents. And we are going to write our security rules later once we have posts and comments being created by the users. And then we have indexes, which is basically not really important for now. It allows Firebase to efficiently query your data. We will add some indexes to our database in a little bit, but it's super easy. With just a single click of a button, it will add the index, so nothing to really worry about here. And usage just indicates the activity going on in your database in terms of read, writes, and deletes. So you can kind of monitor what is going on in your database and how heavy the load is. For now, we're only going to be really concerned with data. That's just a little brief introduction to the Cloud Firestore console. So once we create the community collection, which when we call this function for the very first time, that collection will be created, we will see it in here, and we'll also see the document of any community that we create inside of that collection as well. And the way in our app we're going to access our Firestore database is going back to this client app file that we saw earlier. It's going to be through that Firestore object, right? This get Firestore is basically going to give us access to our database. So we're going to be importing this in any file that we're trying to read, write, trying to do anything with our database. Okay. So let's start off with this function. So since we're doing some community name validation, we do need to add a error state to indicate to the user if something goes wrong. So we just need to create error and set error, and that's going to be equal to use state. And it's just going to be a error message string that we're going to initialize as false. And once we have created that error, let's just go quickly add the piece of text that's actually going to show that error if it does happen. That's just going to be underneath this characters remaining text. We're just going to add a text here with that error actually inside of it. So just do error. And the styling we're going to apply to it is just going to be font size of 9 point and a color of red. and then just some top padding of 1. Awesome. Let's go back up here and let's come back to our app over here. So to make sure that the actual name string is valid, we need to check that it does not contain any special characters. And then we're just going to make sure that it is at least 3 characters because we're already validating that it's 21 characters with our character count. So we just need to check for a length of at least 3. So basically we can check for special characters inside of our string using regex. Now I found this solution on Stack Overflow for this. I will link this in the description, but basically we're going to use regex to make sure that nothing inside of this particular array is going to be inside of our community name. So all we need to do is just copy this really weird looking thing over to our file. And I'm just going to change this to a constant variable. And all we need to do to test that our name does not contain any of those things is to just say format.test and then pass in our community name. This is basically just going to do a quick check on all of those characters. And then we have to also add, or if community name dot length is less than 3, we are going to set an error saying that community names must be between 3 and 21 characters. And also we'll add and can only contain letters, numbers, or underscores. And this really ugly looking regex expression basically just checks for valid string characters. And also if we do get this error, we just want to return out of this function because we do not want to actually proceed with the creation. All right, so let's come back to our app. All right, so inside of here, we're actually going to now create our community. So we need to basically check that name is not taken. And then if valid name, create community. So the way we're going to check if a community exists is to create what's called a document reference. This document reference is basically just a reference to a specific document in our Firestore database. And the way to create a document reference, we're going to say const community docref is equal to doc. Now this doc function is coming from Firebase/Firestore, so make sure that's imported. And then we're going to pass it our Firestore object that I was talking about just a few minutes ago from our client app. That's how it's going to connect to our actual database. And now this doc function as a second argument, we need to know which collection we're actually looking at, like a document in what collection. And so the second argument is going to be that collection name. And that collection name right now is communities. And there's a third argument, we need to know the ID of that document. And in this case, the ID is going to be the community name. Because names on Reddit are unique, we can use the name as the ID. So just to read over this one more time for clarity. So this is basically just a document reference to the communities collection, and it's referencing the document with the ID community name. However, this is not the document itself. This is just a reference. And this is basically just how it works. In Firebase, we have document and collection references, and then we have the documents and collections themselves. And then we can use those references to actually read and write from those two things respectively. And this will become a lot more clear once we start working with them a lot more. And we always just pass our Firestore object as a first argument. This is basically just a requirement by any of the Firestore functions provided to us because they need to know which database they're actually looking at. So now we can actually go and try to get that document with this document reference from our Firestore database. And the way we're going to do that is we're going to say const community doc. This is going to be the actual document. This was just a reference to the document. This is going to be the actual document we're going to get. And the way to do that is going to use a function called getDoc, provided again by Firestore. And all we need to give this function is a document reference so that it knows which document to get. And that is going to be our reference just defined above, which is community docref. Perfect. And we are going to see this so much. We're going to be working with this getDoc and doc, all these functions. We're going to see a ton. We're going to be doing a ton of document references. So this is the first look at it. So if it is kind of weird, do not worry. It will become very, very clear. And with repetition, it becomes very intuitive. So now we can check, does this document actually exist? Like, if we go and grab this document, is there anything there? Well, lucky for us, Firebase has a method on their documents called exists. And this is going to be false if it does not exist and true if it does. So we're saying if this document does exist, meaning that this community with this name has already been created, we need to alert the user, and we're going to say set error. Sorry, name is already taken. Try another. And actually, the exact string on Reddit is going to be the string, sorry, r/name, community name is taken. Please, or not even please, they don't even say please, How could they not say please? Try another. And the way to do this is just with a template literal, the backtick notation in JavaScript. Awesome, and then we can return out of this function because we do not want to proceed after that. If we get to here, line 75, we have a valid name. We have a unique name of a community that has not been created yet, so now we can actually create the community. And the way to do that, with a single line, we can just say await setDoc, and setDoc is a function provided by Firebase that will either update the existing document or create a new one. And what we need to pass this function is a reference to our document. So we can say community docref, and then we're just going to pass a JavaScript object, which is going to represent the data inside of that actual document, like the actual content of the document. And our community documents, to start off, are going to have a creator ID, which is going to be the currently signed in user's ID because we ourselves are creating the document. We're going to pass a created at timestamp to know when this thing was actually created. We're going to have a number of members, so we know how many members are in this community. And then we're going to have the privacy type. And our checklist is going to indicate that. Are we public, private, or restricted? And we could put infinitely many things, right? I'm sure Reddit has a ton of stuff stored on their community in their database. But for now, this is going to work perfectly for us. So we actually do need the creator ID, and to do that, we need our user. So let's call that useAuthState hook. We can import it up here. We can say const user is going to be equal to useAuthState, make sure that imports from React Firebase hooks, and then pass it our auth object from our client app file. Awesome, now we can come down here and we can say creator ID is going to be our user.uid. The created at value, we're going to call the function called server timestamp. And this is basically just going to create a timestamp of the current time. And this server timestamp is a function that is coming from Firebase Firestore, so make sure that that imports up top here. Our number of members is going to be initialized as 1 because when this community is created, we are going to be the only member. And the privacy type is going to be our community type, which is coming from our checklist. You can get rid of these comments, and we just need a comma here. So now we have actually valid code to create this document. So let's test this out and see what happens. And before we do that, actually, I'm going to also create some loading state up here so that we can indicate to our user that the creation is in process. So loading, set loading is equal to useState, and we're going to initialize it as false. When this form is submitted, meaning that they click on the Create Community button, after this validation has been done and it's going to actually start going to talk to our Firestore database, I'm going to set loading to be true. And then when this successfully completes, I'm going to be set loading false. And actually, what I'm going to do is wrap all of this asynchronous code in a try-catch block to improve our error handling. I'm going to create a try-catch block. And the way to do that in a shortcut is to just check the word try, and this little menu will pop up, and just click on this try catch thing. And what we're going to do is put all of the stuff that we want to try inside of our try block, and then inside of our catch block, meaning that an error actually occurred, console log the error. So usually in my catch blocks, I like to indicate what function actually produced the error. So handle create community error, and then I can just log the actual error. And under here, we're going to set error to be error.message. We just need to give this a type of any. And actually what we're going to do is up here, instead of setting the error up here, what we're going to do is we're going to throw an error. And then that error is going to be caught by our catch block, and then we will set that error down here. It's going to do basically the exact same thing. To change that is basically just copy this string here, copy that, we can get rid of this line and just say throw new error. And this thing just takes an argument that is a string, and that is going to be the error.message that we receive down here. So same functionality. And we don't need this return thing anymore, actually, because if we throw this error, it's going to be caught by this catch block, and none of this is actually going to be executed anyway. So I'm going to get rid of these comments just to create a bit of room. And then I'm just going to add a comment down here just for you guys. So if you're reviewing this code later, check if community exists in DB. Okay, awesome. So this looks pretty good. I don't see anything wrong with this. So let's try to actually call our function. We have loading state and everything, which is nice. Let's come down here. And when we actually click on that create community, we now have a function to call, which is going to be handle create community, and let's pass our isLoadingProp, and let's make that our loading state variable. Perfect. Now let's see if this works. So let's go to our database. We can see that it is empty. Let's come over here and let's actually try to create something. So I'm going to create a community called Shaddy's community. Let's click create community and see what happens. Okay, so something happened. Let's go see if it's in our database. So let me refresh. And boom, check that out. It has created a communities collection as well as a document with the ID Shaddy's community. And this is the data we're storing in that document. So hopefully this gives you a visual idea of what our database is going to look like. It's basically just collections and then documents. So we obviously have created a community. Let's go check out error handling. So let's say I try to create this community again. What's going to happen? So check that out. Our error was caught down here, handle create community error, and we displayed that to the user. Sorry, this community name is taken, try another. How nice is that? So let's create another one called new, and click create community. That should have been created. I'm going to also make it so that the error, that on submit, I'm just going to check if an error does exist. Let's just set the error to be empty so that it's sort of a fresh submittal. So this should have been created. So I'm going to create a new one saying random string. And I'm going to click create community. Awesome. So let's go to our database. And we can see that these have been added to our database. And the data is actually real time, which is really cool. So watch this. Do hey dude, and I create it, watch on the left. It appears there. And that is so cool. And we're going to see how sick real-time data is. This is so useful for like chat applications and stuff. But this is cool. It's super, super cool. I love Firestore. So now we can actually create communities. All right, you guys. So now that we can successfully create communities, the next logical thing we need to start thinking about is people actually joining these communities, because without people inside of a community, it's not really a community. So this is going to lead into a really interesting conversation about modeling data with a NoSQL database. And it's going to hopefully provide a really interesting learning opportunity for us to compare how we would model this type of data in a SQL versus NoSQL database. I'm going to do some comparisons here. So I just want you to kind of think about like what actually happens when a user joins a community, like from a data standpoint, because there are two things we need to know. From a community standpoint, we need to know how many users are inside of a community. And from a user standpoint, we need to know which communities a user is in so that I can go to my communities, right? Our drop-down menu in the demo does that. These are all the communities that I am in. And our entire feed and all of the posts that we see is built off of what communities that we're in. And from a community standpoint, I need to know how many members are inside of this community. And let's think about the relationship between a user and a community. A user can be a part of many communities, and a community can have many users. So therefore, we have what is called a many-to-many relationship. Now, this isn't a course on database relationships, but I do want to cover this a little bit because it's really important to understand this before we move forward. If it's your first time using like a NoSQL database, really good opportunity for learning, I think. So what I've done is I have created this diagram here, which I'm just going to expand this over a little bit. And basically, this is how we would model this type of data in a SQL environment. In order to model this type of relationship, which is many-to-many, we would need what's called a join table. And this is a join table here, right? Again, a user can have many communities. I can join as many communities as I want, and a community can have infinitely many users. So to model the many-to-many, we would need a join table. However, in NoSQL, we have a lot more freedom, and we can store data completely differently, pretty much however we want. This does make our lives easier. It gives us more freedom, but it also introduces complications because you can run into scalability issues really fast if you don't think through how to best model your data in a NoSQL database. Now, this is not like a course on like SQL versus NoSQL, but I do want to sort of compare a few methods here. So I just wanted to show this diagram to give you a visual representation of how this relationship would be modeled in SQL. Let's look at how we might do this in a NoSQL database, which Firestore is. All right, so what I've done is I've created this temp.js file to kind of show how this freedom in a NoSQL environment allows us to develop many solutions to the same problem, and we can model our data in many different ways. Normalization is not required, and we can therefore have this nested structure here. We can have arrays of strings. We can have arrays of arrays of arrays of strings, of objects of strings. We can do like whatever we want with our data, which is really great. It can simplify our lives a lot, but it does come with some cost, because if we don't do it carefully, we could run into some major issues down the line, especially when scalability comes into play. So what I've done here is I've just sort of created 3 different solutions here that we're going to go through quickly to sort of illustrate the thought process when designing data with a NoSQL database. The number one thing that I learned when modeling data with a NoSQL database, something I saw on Stack Overflow, was someone said, when you're modeling data with a NoSQL database, the number one thing to think about is how your data is actually appearing on the screen. Like when you look at a certain component, what data is there? And it really helps you efficiently kind of think about where to have this sort of nested structure and where to group things together on your document. And this is sort of something that just takes practice, and you just have to like kind of honestly practice developing NoSQL databases for different sorts of features in order to really understand how to develop the optimal structure. Now, as we go through these examples, let's keep in mind the relationship we need. We need to know how many users are in a community, and we need to know what communities a user is in. So let's look at this example. These represent a community document and a user document. Okay, so what we could do is we could store an array of all of the users that belong to a certain community, right? Every time I join a community, I could add that user's ID to this array. So now we know how many users are in a community, and these comments just kind of represent other data that would be stored on the community document. But let's think about scalability. On Reddit, communities can have, millions of users, infinitely many users. There are some communities with 20 million plus users, I'm pretty sure, right? That's a lot. And in Firebase, our documents can only be 1 megabyte in size, which is about 40,000 fields. Now, we're obviously over that 40,000 limit here. We're sort of in the 11 million area, and this is totally realistic for Reddit, right? And I know that our little demo app is not going to have 11 million users or 30 million users, but it's really good to think about these things and just kind of think about it, how it would be in the real world, because it helps you become a better engineer. This is not great because this array can get infinitely long, and it definitely puts us over our limit. So from a user's perspective, we could store all of the community IDs that I am in on a communities array inside of the user's document. For example, like the Tesla ID, the baking ID. And this is totally fine. I don't see any scalability issues here because a user is probably only going to join 20 to 50 communities, like 50 is even a lot, I think. I don't know. So I think this type of approach is fine where we're storing, the communities on the user, but this is definitely not. And so I think this could work, or some variation of this could work, but we would have to sort of tweak the community logic a bit. Let's talk about option 2. So option 2 is essentially just the SQL approach, right? This is option 2. What we do here is basically create a collection in our database that would sort of mimic this sort of SQL-like join table over here. But having this SQL-like structure calls for SQL-like queries, which would be like join statements and, just querying multiple tables. And Firebase does not support join statements. Therefore, we would have to make multiple queries. And one of the main benefits of NoSQL is that we can actually use this nested structure to our advantage to prevent that. We can prevent making multiple queries. We can prevent join statements and really simplify our lives if we just do the nested thing properly. So that's why we're going to avoid having this SQL-like structure for this case. Now, let's talk about option 3. And this is the solution that we're actually going to go with. The user document in this case is quite similar to case 1, where we had just an array of community data stored on the user. And so we know what communities a user is in. However, in this case, we're not storing just the ID. We're storing an array of objects, and those objects can contain sort of snippet-like data of that community, hence the name community snippets. Now, why is this useful? Well, A, this is useful because what I mentioned already, we know all of the communities that a user is in. And B, this is useful because what if in some of our components, we need more than just the community ID itself, but we don't want the entire community document. We want somewhere in between. Let me explain this with an example. Let's come to our demo. And if we look at this drop-down menu here, we can see that we have this list of communities that I'm in, but we really only have the name and the profile picture. We don't have all of the data associated with all of these communities, right? And we don't really need it. Like when Shadi lands on reddit.com, I don't really care about all of the data in Tesla, all of the data in NBA, all of the data in music. I don't care about that when I'm on this page. I just care about the names of the communities that I'm in and the profile picture. So in this list component, the name itself, which is also the ID, is not enough but the entire community is too much. When I click on one of these things, then I care about all that data. Then I need to know how many members are in the community. Then I need to know the created at and all this other potential data that could exist, right? Reddit probably has tons of data stored on their community documents in their database. This design is perfect for what we need because it allows us to store just the minimum amount of data we need for each community to display it, but we're not overfetching data. We're not getting data about each community that we don't really need. And this is really good from a front-end scalability perspective. We're not overloading our front end with a bunch of unnecessary data. We're just grabbing snippets to present it in a meaningful way. And in this case, all we need are two things: name, profile picture. So as for the community, for a community, all we need to know is the number of members inside of a community. I don't need to know every user that's in the community because on reddit.com, you can't really go into the list of all of the members in that community. I don't need that for Reddit. Maybe I would for another app, but for Reddit, all I need is the number of members, right? If I go to a community page, all that they're displaying here is the number of members. So in terms of like the relationship between users and communities, I only care about this. And then all we need to do is every time a user leaves or joins a community, we just have to update this number. If this was clickable, if I could click on this and view a giant list of all of the users in a community, maybe that would call for a join table like this. We are going to go with this solution here. It seems to satisfy all of our needs. It models the many-to-many relationship. Okay, that was a lot on SQL versus NoSQL. I hope that did clarify things, and I hope it was insightful to kind of see different examples of ways we could solve this problem. If you got absolutely none of that, I apologize. And as I always say, if this does not make sense at first glance, just give it time, let it kind of absorb into your brain. And as we develop it into the app, it should become more clear. And this document structure will also get us into using database transactions, which we're going to see next. All right, you guys, now that we have solved the problem of users joining communities, we can now actually implement that data structure into our app. So as you recall from our discussion about NoSQL, we do need to create a sub-collection on our user document called community snippets and store these little pieces of data in there every time I join or leave a community. So that is what we're going to do now. But we have a small problem. Let's go to our Firestore database for a sec. So if you look at this, we actually do not have a collection called users, which is weird, right? Like we have the ability to log users in, but we don't have them in our database. It's kind of weird, isn't it? Yeah, it is weird. So the way Firebase works is their authentication is completely separate from their Firestore database. They're not linked at all. It is meant to be an authentication solution only. So in order to add custom things to our users, like I was mentioning before with the karma score and usernames and anything that's custom, and in this case, the community snippets subcollection, we need to store these users in our Firestore database. We somehow need to get them in here. And this is where we're going to talk about Cloud Functions, which should not take very long at all. It's just going to be a few minutes. So what we're going to do from a high level is just implement functions into our app. And we're just going to write a single function that is going to be listening to our authentication service. And then every time an authenticated user is created, it is going to just automatically store that user in our Firestore database. And then once the users collection is in here, it'll appear the same exact way these are. But then we can actually add custom things to it. So let's go ahead and do that very quickly. It shouldn't take any more than 5 to 10 minutes. So once you go into the function section of the console, you might see something slightly different than this. I already clicked like the get started button. If you're there for the first time, you might look a little bit different than this. I can't remember exactly what it looks like. But basically what this is saying to me is that I need to upgrade my project. So to use Cloud Functions, we need to upgrade our project from a free project to a pay-as-you-go project. But do not worry, you are not going to be charged a single cent. In order to be charged anything for Firebase, your app has to have like millions and millions of users and millions of reads and writes to your database. You are not going to be charged a single cent. To sign up for a billing plan, it will ask you to enter a credit card. But if for some reason you do not want to proceed with Cloud Functions for whatever reason, I'm going to also right after this do another workaround solution without Cloud Functions to achieve this same functionality of getting our user into our database. However, I would recommend you, if you are able to, use Cloud Functions as it is the recommended method by Firebase and the community for this type of user authentication. authentication flow, totally up to you. So I'm going to quickly walk through the Cloud Firestore solution. And then right after this, I'll just do like a quick 5-minute chapter on doing the same exact thing without Cloud Functions. So depending on what you want to do, watch accordingly. Okay, so to proceed with Cloud Functions, let's click on Upgrade Project or whatever is there for you. Just click on it and it'll sort of take you down a similar path. So if it's your first time seeing this, it's probably going to ask you to create like a Google Cloud account or something. And that's where you're going to like actually put in like your billing information, like a credit card. And I already have my account created. So it's just asking me to set a billing budget. I'm just going to put $1. I'm not even going to be charged $1. And it's just basically saying you will be charged as you go. Don't worry, no charges will occur, I promise. And I'm just going to click purchase. And now it says you successfully upgraded. Okay, so once you've upgraded your project to a pay-as-you-go plan, we can just click get started and we're going to install a few packages. Okay, so let's click on this and let's go to our project terminal and just install that. The $ always gets me. Okay, so something I just noticed that some of you may come across as well is when I tried to run this command here on the right, it gave me an error that I do not have permissions. So I just needed to change the command to use sudo. So I just added sudo in front of the entire command. Cool. So once we have the Firebase CLI, we can just click continue. And now we're just going to run a few commands inside of our project to initialize Cloud Functions and then deploy our functions. So after we initialize our project, we will then deploy them so that they are actually deployed on the cloud and we can use them. All right, so let's do Firebase init. Okay, so right now we just want to set up functions. So we just highlight the functions option and press the spacebar. And then we just press enter. And it's going to ask us which project we would like to use an existing project because we have created a project on our console. And the one I want to link up is Reddit clone tutorial, I believe. And it's saying, what language would you like to use to write Cloud Functions? We are all about TypeScript. Do you want to use ESLint? And I'm going to say no. Do you want to install dependencies with NPM now? For this, I'm just going to say yes. So I'm going to click finish over here. Our app should have functions and it's waiting for us to deploy. So if we come over to our directory, you will see that in the root of our project, we have been given 3 new things. We have this firebase.json file, we have this firebase.rc file, and then we have this functions directory. Now, this is where we're going to be writing all of our Cloud Functions in this index.ts file. This functions directory is your serverless backend. It's being run on the Google servers, and it may require different packages than your front end. You'll notice that if you go to your package.json file, it has these 2 dependencies, Firebase functions, which makes sense, and it also has this Firebase-admin package installed, and it's through this admin package that we're going to be able to actually interact with our database. So let's go see how we can do that. So here we are inside of index.ts, and I'm just going to get rid of all of these comments. And at the very top here, I'm just going to say import star as admin from Firebase admin. And on this admin instance, let's call this method called initialize app, which is basically just going to boot up our app on the server. And then we just need to create a database instance so that we can actually write to our database. All right, and underneath here, we're actually going to write our function. So we're going to say export const, and our function name is going to be called create user document. We're going to use our functions instance and tap into our auth service. And then we're going to say .user because the user is the part of the auth service we're interested in. And then we're going to say .onCreate. And then we're going to give this a callback function that is going to trigger every time a user is created. And this callback function is going to be asynchronous, and it's going to take in a user as an argument. I'm going to save this so that it formats. Inside of this function, we're going to say db.collection. And the collection that we want to write to is users. And we want to set a document by saying .doc. The ID of the document we're going to create is going to be user.uid, the ID of the user. And then we're going to set this document to be json.parse. And then inside of json.parse, we're going to say json.stringify and then the user. And this is kind of a weird workaround that you have to do. If you do not do this, you will get a serialization error. And this just seems to be the solution among the community. That is our entire function. It is just a few lines. And now we are ready to deploy this function and actually store users in our database. So let's go back to our terminal. And there is a command that we're going to run that is going to deploy only functions, because right now we're only interested in deploying functions. So I'm going to copy this over and paste this in my terminal. Now, this may take several minutes to run the first time you run it. It usually does speed up after the first time, but I think the first time it sort of has to go and actually provision the resources on the Google servers. So just give it a few minutes. Okay, so once yours has successfully deployed, go back to your console and you should now see that function inside of this dashboard here, and you can see what the trigger is to actually trigger that function. So it's pretty cool. And the logs are a good place to look if the function ever fails or there's some sort of bug. The logs usually have details on what might be going on. So now let's actually go try this out and try to create a user and see if it gets stored in our database. So I'm going to go to my app and log out. Let's click sign up. Now let's create a new user called Shadi at shadi.com. Password is going to be Shadi. Actually, and before we do this, let's go to our Firestore database, and we can clearly see we do not have any users in here. So let's see if it is created. Let's go to here and click sign up. Let's go to here. It sometimes takes a second as well. It might take like somewhere between like 5 to 10 seconds. So refresh, and there is no user, which is odd. Okay, let's go to functions. Let's check the logs. Okay, so this was at 9:24, so just now, pretty much. Function executed, finished with status error. Oh, okay, it did not work. Entry.toJSON is not a function. Okay, I don't even know if you can see this. Sorry, this is really, really small. I'm getting a toJSON error, which is really weird. I think it has to do something to do with this. I don't know why, because I have this written the exact same way in my demo. All right, so I did some research on this, and I'm honestly not sure what is going on. I have no idea why I'm getting an error and why it's not successfully writing to the database. It definitely has to do with this, because I tested out just writing a plain JavaScript object to the database, and it did work. So this function is being triggered, and we can obviously see it's being triggered from the logs. So I have no idea why this is happening. I did the exact same thing just a few weeks ago when I built the demo, so no clue what's going on. And I don't want to spend too much time on this because it's not extremely critical. So for those of you that are experiencing the error as well, I'm just going to do a quick workaround solution. If you're not having the error, that is amazing. I hope you're not having the error, but if you are, this is a potential workaround. So what we can do is we can just create a new JavaScript object, and we can store basically just the most important parts from this user object onto this new object. And if you look at kind of what might be on this user object, there's a lot of stuff going on here, and a lot of it is kind of nested. We don't really need all of this data, especially for our application. So I'm just going to store the most important things, which are like the UID, the email, and like the photo URL, and like maybe the provider data so that we know if they authenticated with Google or something, just the most important things. So like 4 things. So I'm just going to take this user, and I'm going to say UID is going to be user.uid, email is going to be user.email, display name is going to be user.displayname, and this is only going to exist for OAuth users, and provider data is going to be user.providerdata. Okay, and then instead of this JSON.parse.json.stringify thing, I'm just going to pass in new user, and this should work. So if you did have to implement this change, we will have to redeploy. So let's go ahead and do that. And once this is done, we will check back in. All right, so I'm going to try this again. So I'm going to go back to my app. I'm going to log out and then do this whole thing again. I'm going to create a user called lol at lol.com. I love lol.com. It's one of my favorite websites. Just kidding. I have absolutely no idea what's at lol.com. Sorry if there's something not good. Okay, and then let's go to our database and see if this actually worked. Okay, so it's saying that it's successfully completed. Sorry if this is super small, but basically it says that it finished with a status of OK. So let's go to our database, and yeah, look at that. So the users table has been created, and that data that we indicated has been stored in there. Now, if yours worked with our initial solution with the JSON.parse thing, there'd be a lot more stuff in here, but this is really all we need, and it's on this document where we're going to create that subcollection community snippets. So now I'm going to implement the solution for getting our users into our database without using Cloud Functions for those of you who chose not to do them, and it's actually very, very straightforward. It's only a few lines of code. Okay, so let's start off with our signup component. And so basically what we're going to do is in the signup component, once a user has been successfully created with this create user with email and password function, we're just going to put it into our database. That's it. So this function itself does not return the newly created user, but we can access it as the second parameter from the hook. Up here, remember these 4 arguments, and it's called user cred because this is not the user object itself. It is like the user credentials, but the user object itself is on this object here, which we will see in just a second. Okay, so I'm going to create a function called create user document, and it's going to be an asynchronous function that takes in a user, which is of type user from Firebase. Okay, so the way we're going to write this user to our database is with a function from Firebase called add_doc. Now we basically just need to tell this function what collection we are writing to, so we can create a collection reference using the collection function from Firestore, and then we can pass this function our Firestore object from client app, and then the collection that we want to write to is users. And then as a second argument, we're going to pass the actual data that is going to be written into this document. And in that case, it is user. Now all we need to do is just call this function. So what we can do is we can create a use effect, and this use effect can have the dependency user cred, so that every time user cred changes, it will run this function. And if user cred is a non-null value, meaning that the user was successfully created, we want to do something with it, and that something is write it to our database. So we can call our function create user document, and we can pass the user object. And the user object is going to be user cred.user. And that's what I meant before when I said you can access the user on this user cred object. So when we do that, this should work exactly the same as our cloud function. So let's go test it out. Hey guys, really important announcement I have to make as I am editing this video here. Please change this user that the arrow is pointing to and wrap it in JSON.parse, JSON.stringify. Firebase will not like it. If you do not, it will error out and it will not work. The solution shown in the video does work for the first attempt, but it eventually does fail. So I did have to refactor this part of the code. So please implement this. I do apologize for this confusion. So right now I only have a user called lol@lol.com. So let's go create a new one. Sign up. Let's sign up as dude@dude.com, password chatty, sign up. Okay, let's go check our database. Users, we can see that dude@dude.com is in there. Perfect, so it did its job. So we just needed these two additions, the use effect and the create user document. Now we can do pretty much the exact same thing in our OAuth buttons. So we can pretty much do the exact same thing in here. I'm just going to rename this user cred. And I'm going to create a function called create user document, same name as the other one. It's going to be async. It's going to take in a user. Now inside of this function, the only difference between this and the sign up is that in this function, we're going to call setDoc. The other function was calling addDoc. So we need to call setDoc because when you're authenticating with Google, we don't know if you're logging in or signing up. We don't know if you're new or if you've already been here before. The setDoc function does that functionality. It's either going to create a new document if it does not exist, or it's going to update the already existing document. So it can handle both the login and sign up case for Google perfectly. Okay, so what we need to do is create a document reference to that potentially existing document or the new document. And the way we can do that is we can say const user docref is going to be equal to doc, pass it our Firestore object. The collection we're interested in is users, and the ID of this new or existing document is going to be user.uid. And all we need to do is just say await setDoc, pass it our user docref, and then just give it the data that we want to set the doc to be, which is user. And we use the same setDoc function when we were creating our communities. And we can add pretty much the exact same use effect in this function. Give it a dependency of user cred. Check for a non-null value of user cred. And if it is not null, we can pass it to our create user document function. User cred.user. Save this and let's give this a go. Hey guys, we need to do the exact same thing here, so please wrap your user in the exact same thing we did just a few seconds ago. Thanks. So I went to my authentication thing and I have no Google Auth user right now. So let's go try to create a thing for my shadi@gmail.com account because that's the only Google account I have. Let's sign up, continue with Google. So it's going to authenticate. And if I go to my database now, Firestore, I should see a third user. And yes, I do. shadmary@gmail.com. It says the provider ID is google.com. So perfect. Now we can write users to the database, whether or not you use cloud functions or not, and we can proceed with the community functionality. All right, you guys, now that we have users in our database and we're able to actually add custom properties to those users, let's move forward with our community logic and actually build in this community snippet functionality. So now we are ready to introduce what is called a database transaction. And a transaction, by definition, is a set of read or write operations on one or more documents. And transactions are really useful because they represent an all or nothing operation. So what that means is if you have a set of database operations that you are doing, like updating several documents at once, it is very useful to have all of these things succeed or none of them. If one of them fails, let's fail them all because they're sort of dependent on each other. So in our case, when a user creates a community, we are doing two very important things. The first thing we're doing is we're actually creating the community itself in the communities collection. And the second thing we're doing is we're going to add that community to the user's community snippets, right? We are automatically joining that user to the community if they create it. and we either want both of these database operations to succeed or none of them. So we do not want to create the community if the community is not successfully added to the user's community snippets, and we definitely do not want to add the community to the user's community snippets if the community fails to be created. And so that's why transactions are extremely useful here. Transactions are very similar to batch writes, and we're going to see batch writes very shortly. There's just a slight difference between the two, but I will talk about that more when we get to it. Okay, so let's go to our app. Okay, so here is how we implement a transaction in Firebase. So we are going to use an asynchronous function, and that function is called runTransaction, and this is coming from Firestore, so import that. The first argument to this runTransaction function is our Firestore object as usual, and the second argument is going to be a callback function. And this callback function is going to be asynchronous, and it's going to give us this transaction object that we're going to use to actually make writes to our database. So what we're going to do is we're just going to add this first check into our transaction, checking if the community exists in our database. Rather than calling this getDoc function, we're going to change this to transaction.get. Pretty much the same thing. We are just making it part of the transaction now. The next thing we want to do is we want to create the community. So let's move this up here. And we are going to change this from setDoc to transaction.set. Transaction set operations are not asynchronous themselves because the entire transaction is asynchronous. We don't need to put the await keyword in front of our transaction sets. We do need them in front of our gets though. And the next thing we want to do is create the community snippet on that user. We're going to say transaction.set. So what we're going to do is write a new document to the community snippets subcollection, which lives on the user document. So we're going to use the doc function from Firebase. We're going to pass it our Firestore object. And the second argument to this doc function is going to be the path to the document we're about to create. And paths are absolute paths, and they start at the root of our database. So if we go to our database, this is the root, and then we just have to sort of jump into each column here. That's sort of like how you can think of a path. We're going into here, then into the new thing. So the path in this case is going to be users because we're going into the users collection. The ID of the user document we're interested in is user.uid. And we are writing to a subcollection, and the subcollection name is community snippets. So this is the first time we've seen this path notation. And the way I want you to think about this is collection, document, collection, document, collection, document, and you can go as deep as you want. In our case, we're going into the user's collection, the current user's document, and then that current user's subcollection called community snippets, collection, document, collection. The third argument of this doc function needs to be the ID of the document that we're creating, which in our case is community name because their names serve as IDs. And now let's hop out of our doc function. And as a second argument to the set function, we need to just pass in the actual data that we want to store in this document. And the data in this case is our community snippet. The community snippet has a community ID, which is just community name. And then we're going to add another property called isModerator. And the isModerator key means, am I a moderator of this community? And we are setting it to be true here because if I created the community, I'm automatically being set as a moderator. And I'm going to be given different permissions than other users who are not moderators. And that is it. That is our entire transaction. So if one of these things fail, all of them are going to fail, which is really good, and it maintains a high level of data integrity. All right, so let's actually see this in action and see if it works. What we should see happen is the new community should show up here in communities, and then if I go to the users collection and go to the actual user that created the community, we should see a sub-collection inside of that document, which should have the newly created community snippet on it. And hopefully this will clarify this sort of path structure once we sort of have a visual representation of what it looks like. All right, so I'm going to use a user that I know exists. So let's use lol at lol.com. Let's go to our app, and I honestly do not know who I am logged in as right now. So I'm just going to log out. Actually, I could have just checked the username. Wow. Whatever. Okay, so let's log in, and let's use lol at lol.com. Sign in as Shadi. And let's go to here, create community. Let's create a community called lol's new group. I have no idea. That's a terrible name. Okay, create community. All right, no errors that we see. So let's go to our database and let's go to communities. So we see lol's new group, which is perfect. That's awesome. Let's go to our lol user. Okay, so we're at lol.com, and now we can see that there is a sub-collection on lol.lol.com document called community snippets with an ID of lol's new group, and the community ID is in here is moderator true. And now you can kind of see that path structure that I'm talking about. So users, user ID, and then community snippets, and then the ID of that community snippet, and then the actual document at that field. And later when we add profile pictures to our communities, this is where that URL is going to be stored as well. All right, so now we know what communities that lol.lol.com is in, which is super cool. So our transaction is working successfully. All right, you guys, now that we are successfully able to create communities and store those community snippets on the user so we know what communities each user is in, let's now create the community page itself. And this is going to be our first look at server-side rendering with Next.js. So inside of our pages directory, we need to create a folder structure that reflects the community page route. And if you go to Reddit, their page route is reddit.com/r/community name. I don't know if you can see this, it's super small, but it's r/community name. And in this case, it's comp sci, but this can change, right? There's infinitely many communities. So our folder structure needs to be very similar. And remember that the folder structure in your pages folder represents your client-side routes. And our client-side route in this case is r/community name. So inside of pages, we need to create a folder called r. And then inside of r, we need to create another folder called community name. But this community name is going to be a dynamic route because the route changes. It could be computer science, it could be reading, it could be baking, it could be Tesla. So it is dynamic. And the way to do dynamic routes in Next.js is to put these square brackets around it. And then inside of these square brackets, we actually put the name of the dynamic variable. And in this case, the dynamic variable is community ID. So we're going to say community ID. And then inside of this folder, we can create a file called index.tsx. So we can access this index route by going to localhost 3000/r/some community name. And so just to really illustrate this client-side routing concept, while we're here, let's create another file called submit.tsx, because that's going to be the page that we actually create posts on. So if I go to our demo, we have our r/baking route. This is the homepage of the community. But then if I click on this, I go to the submit page, which is r/baking/submit. Index is the home page, submit is the submit page. All right, so let's go back to our app. So let's start with the index page. So we're going to start off by using our snippet as usual. And I'm just going to rename these props to be community page props. Rename this one as well, community page props, just like that. And then I'm going to rename the component itself to just be community page and community page. And I'm going to put the text in here, community page. So now if I go to localhost 3000/r/heydude or something, it's going to take me to this page that should say community page. So we are actually on this page now. And soon we're going to see how to actually grab this from the URL and do something meaningful with it. So for this page, we are going to use server-side rendering. And to do that, we're going to use a function from Next.js called getServerSideProps. GetServerSideProps is called on the Next.js server, and then data is fetched from our database in this function and then passed to the component, and then the component is rendered on the server and then passed to the client, and then the client renders the component. That's sort of the path. So when the user actually makes a request to a web page, all of this stuff happens behind the scenes on the server. And so I would basically just think of this as the web page being pre-built before it's actually shown to the user. And this whole process just makes it appear as if the data on the web page is just sort of magically there when the user first sees it. Whereas in client-side data fetching, we would show the component first, then go get the data, and then use that data to update our component, and the user would just see some sort of loader as the data is being fetched. So server-side rendering basically just removes this loading state. And Reddit.com uses a mix of both server-side rendering and client-side rendering, so we are going to do the exact same thing. So the data that we're going to server-side render on our community page is going to be the community data, so that we can sort of pre-render the page with all of the community data in it, and then show it to the user. All we need to do is export the function getServerSideProps from this file, and Next.js will automatically know to server-side render this page. So what that looks like is this. We say export async function getServerSideProps, and we're going to take in this context variable, which is going to be of type getServerSideProps context, and this is how we're actually going to access the page router so that we can use the community ID. And I'm just going to close my directory on the left so that I have a bit more room. Inside of this function, we're going to get the community data and pass it to our client component. So we're going to have a try catch block. Inside of our try block, we're going to actually try to get the community document. And the way we're going to do that is we're going to say const community docref is going to be equal to doc from Firebase. We've seen this kind of stuff already. Firestore, import all of these things. communities is the collection we're interested in, and the document we want to get is the community ID page that we're on. And that page is coming from the router, right? I went to r/heydude, so I want to get the community data for heydude. So we can access this parameter from the router by saying context.query.community ID. And the name community ID is coming from the name we gave it, right? This dynamic route right here. So whatever name we give this dynamic route is the exact same name we're going to use to access it from our router, in this case, community ID. And so technically the URL parameter can be of type string, or it can be a string of arrays, or it can be undefined. In our case, it's always just going to be a string. So what I'm going to do is typecast this to just a string, and that should solve that compiler error. Okay, so now let's get the actual community document, which is going to be const community doc. I'm going to say await get doc, and the doc we want to get is community doc.ref. Awesome. And so the way Next.js is going to pass this data to our client-side component, which in this case is community page, all we need to do is return an object, and inside of this object, we just need to return props. And this props object is what Next.js is going to pass to our client. So inside of our props, I want to pass community data. And our community data is going to be the actual data inside of this community doc we just got, which is going to be community doc. And then we have to call a function called .data. And that is a Firebase thing. This is how we extract the data from this actual document object. And then in our catch block, I'm just going to log the error. I'm just going to say getServerSideProps error. And Next.js allows you to create custom pages if errors occur inside of getServerSideProps, but I'm not going to do that for this tutorial because I feel like our time is better spent elsewhere. So I'm just going to add could add error page here. So this props object is being passed to our component up here. So what I'm going to do is destructure the props and grab that community data. But we do need to include that on our community page props type. And our community data is going to be of type community, and we have not created this type yet. So let's go quickly create this community type, and we're going to do that in our Atoms folder because we are going to add some global community state shortly. So let's go quickly set up the skeleton for that. So inside of our Atoms, I'm going to create a folder called communities atom. So we're going to eventually define an atom in here that is going to contain global community state that we need throughout our application. But for now, let's actually just define that missing community type that we have over here, because that's really all we need at the moment. So I'm going to create an interface called community. So if you recall, our communities have an ID, which is of type string, a creator ID, which is also a string, number of members, which is a number, privacy type, and the type of this is going to be one of three strings, which is either going to be public or restricted or private. We're also going to have a created at field, which is going to be of type timestamp, and this is coming from Firebase/Firestore. And I'm actually going to make this optional by adding the question mark here, and I'm going to talk about why that is later. And finally, we're going to have an image URL. And I'm going to make this optional right now because when we initially build the community page, we are not going to have it, but I will come back later to add this. But for now, let's make it optional so that TypeScript does not get mad at us. So now we actually have an interface defined for our community. So let's come back over here and we can import that. So import it from our community's atom file, and this file should be happy now. Okay, so I'm going to close the directory so I have some more room. And inside of here, I'm going to render, just so we can see the data coming in, community data.id. So I'm going to add welcome to community data.id. Perfect. Okay, so after refreshing the page, you are very likely to get this JSON serialization error from Next.js. So basically what's happening is Next.js is not able to successfully serialize our community doc data in order to pass it from the Next.js server to our client. And this typically happens when you use timestamps, and we are using a timestamp for our created at parameter in our community. So basically Next.js is just freaking out because it doesn't really know how to serialize that data type. So I did some research on this, and the solution I found was to use a library called safe-json-stringify, and this basically just stringifies our data to a form that Next.js can actually read and serialize. So that's what we're going to do. So we just need to install a package called safe-json-stringify. So I'm going to go run npmi safe-json-stringify. So let's install that. And then at the top, I'm just going to import it. So I'm just going to say safe-json-stringify from safe-json-stringify. and it might complain that we need to install the types for this file. Oftentimes when you're using TypeScript and you install a library, it'll tell you that you need to install the types for that library as well in order for it to work. And it usually gives you the command in this little pop-up window. So let's go and grab that and paste it in here and just install the types. Okay, so this should make that go away and not make it all happy. Perfect. All right, so to actually use this function, let's come down here and change the value of our community data. And the value we want to change it to is going to be json.parse. And we want to parse the stringified version of the data that we want to send. And we're going to do that using the saveJSON stringify function. And we want to pass an object. And this object is going to represent our community data. And on that object, we want the ID of the community. So we can say community doc.id. And then we want all of the data in the community document. So we can just spread community doc.data. And this is a function, .data. And so basically all we did is we just created an object that represents our community. So the ID of the document is not included in the .data function. So in order to retrieve the actual ID of the document, we can just manually declare it here by saying ID is the community doc.id. All right, so now that we're using saveJSON stringify, this should solve our serialization error. So I think I need to run my development server. So let's do that. And you might have to recompile yours as well if yours was running while you did all those installations. Okay, so now let's come over here and refresh. Let's go to localhost. Okay, that seems to be working. Let's go to /r/heydude. And the actual name of the community in the database is with a lowercase dude. So make sure that matches. So it says, welcome to heydude. And we had welcome to communitydata.id. So this ID thing is being shown here, communitydata.id. And you can log the data if you'd like, just so you can see what it looks like. Data. So if I log this thing we're looking at here is this object. So it has the ID. And then we just took all of the other data and spread it. So we have all of the data of the community. And this is that timestamp thing that Next.js was having a tough time serializing. No clue why, some weird conflict with the types. So that is why we had to use saveJSON stringify. All right, so what we're going to do now is just handle the case of if a community doc for the visited URL is not found. So if a user basically goes to a URL for a community that does not exist, we should just display them some kind of meaningful message that's like, this community does not exist. Because on Reddit, if you do that, if you go to reddit.com and you do r/some random community like this, that obviously does not exist, Reddit shows you this page. It's like, sorry, there aren't any communities with that name. So yeah, we're going to do that quickly. It's just a single simple component and it just makes the app slightly more robust and realistic. So we're going to come down here and this is going to be very minor changes. So all we need to do is basically check if this thing actually found something. And if it did not, we're just going to pass in an empty string as a prop for community data. And then in our component up here, we're just going to check if this community data is an empty string. We will show a component that said exactly what Reddit said. Sorry, there aren't any communities with that name. So basically all we're going to do is inside of our client-side component, we're just going to say if no community data, because we do not have a community in our database with this name. We just want to return out of our component early, and we're just going to say div does not exist. And I'm going to add a more meaningful component in just a second here, but just to get the overall flow set up, let's do this for now. And so down here, what we're going to do is just change the value of our community data by adding a simple ternary operator to check for the existence of that community doc. And if it does not exist, we will pass an empty string. So we can say community doc.exists, which is a function conveniently provided by Firebase. If it does exist, pass what we're already passing. And if it does not exist, let's just pass an empty string. So if it's an empty string, meaning we went to a community page that does not exist, this is going to happen because an empty string is a false value. So it's going to return this div and not the div for an actual community. So let's try this out. So in our database, I know that there is no community called dogs, right? There's only these 5. So let's try to go to dogs. So r/dogs. Let's see what happens. Okay, yeah, so it's saying community does not exist, which is great. So all we need to do is just create a very simple component to replace that dummy component that we have in there right now. So inside of components, I'm going to create a new folder called community, and there's going to be a lot of stuff in here. But our first one is going to be that not found component. So I'm just going to say not found.tsx, and I'm just going to paste the component from my demo project because it's very simple. It's just only like 20 lines. So this is exactly what it looks like. So now if I go back to my index page, and I import that component. So rather than showing this temporary div, I'm going to return not found, which doesn't seem to want to import automatically. So I'm going to try, yeah, okay, so add imports from components, community not found, save that. So now we have a more meaningful component that is displayed if they go to a non-existing community. Okay, so now that this is out of the way, we can move to the actual ideal case of when there is a community that does exist for that URL, which is probably going to be most of the time, right? This is just an edge case, but it is good to think about these things. I recommend to just avoid going completely happy path when you're developing your apps, because if you don't cover your bases, sometimes this can be catastrophic in production or something. It could break something. So it's always good to just think about these rare cases that might happen. All right, so let's go to a community page that actually exists. Let's go to new. So r/new. Cool. And just go to one that exists for you. I don't know if you made this exact one, just one that exists. Okay, so if we go to an actual community page, in our demo, we can see that we have this header component, and then we have basically this feed, and then some components on the right-hand side here. So we're going to start off with this header, and it's in the header that they can actually join and leave this community. So let's go make that now. So inside of our community directory, let's create a new file called header.tsx. And I'm going to use our snippet. So our header is going to take in that community data, since we are showing the name. So this is going to be of type community, and we can import this again from their community's Atom file, and then we can just destructure the props in here, community data. So let's build out the actual component. There is going to be some logic that we're going to add inside of this component for the actual joining and leaving of communities. But for now, let's return the component itself. So this is going to be a flexbox from Chakra. Import that. And we're going to give this a direction of column, a width of 100%, and a height of 146 pixels. And I'm just going to add the text header so that we actually have something to show. And I'm going to come back to this index file, and rather than just show welcome to community data, I'm going to actually return just a fragment. And inside of this fragment, we're going to put that header that we just created. Awesome, so we can actually see the header there. Let's go make this thing look actually proper. Why is this red? Oh, yeah, and so we need to actually pass the community data in there. So let's do that. Community data is just going to be equal to community data. Let's go back into here and continue building. Now inside of our header, the first thing we're going to add is a box component, and this box component is going to represent the upper half of the header. That is sort of that blue highlight thing here. So let's go create that. So that's going to look like this. The height is going to be 50% of the header height, and the background color is going to be blue 400. And we can actually just make this self-closing since nothing is going to be inside of it. Underneath here, we're going to have another flex box. This is going to have justify equal to center. We're going to give it a white background. And we can just say flex grow is equal to 1, which basically just means to take up the remaining space available in this component, which is 50%, because we made this height 50%. Now inside of here, we're going to have another flex box. This is where our icon is actually going to go, and we're going to give this a width of 95% and a max width of 860 pixels. And I will explain why this is in a second. I'll add a border to this too, just so we can kind of see what it is that we're creating over there. 1 pixel solid red. All right, so inside of here, this is what is going to be our image URL. For now, since we don't have image URLs, which we're going to add later, we're just going to use the Reddit icon, which will basically just act as the default community image. So we're going to create that icon inside of here. So we're going to say icon from Chakra UI React. And the icon we're going to use is going to be that same icon we've used before, which is going to be FA Reddit. And we're going to import that from React icons FA/FA, just like that. The CSS for this icon is going to contain relative positioning. And the reason that is because if we look at the demo, you can see that there's a bit of an overlap here. This icon kind of overlaps with this blue part. So to do that, we can use relative positioning and kind of customize where that thing is going to sit. So we're going to make this thing a bit bigger. We're going to make it 64, which is about the same size as it is on Reddit. And the position is going to be relative. And because now we have relative positioning, we can kind of customize where this thing sits. So we can give it a top parameter, and we're going to give this -3. So this basically just means it's going to be -3 units away from the top of its parent. And its parent is this thing with the red border, and the minus thing moves it upward, right? If we were to make this 3, it would move it downward 3 units away from the top. Negative means 3 units kind of above the top. And the color of this is going to be blue 500. And we're going to give this a border of 4 pixel solid white and a border radius of 50%. This border and this border radius are the sort of outline around the icon. So you can see that there is the ever so slightest gap in between there. So I think a potentially better solution to what I'm doing here would be to have just a circular icon that is slightly larger than this Reddit icon sit outside of it, and that way you wouldn't have this little gap here. I'm not too worried about that. It's not a huge deal, so I'm just going to leave it for now. I think this works pretty good. Okay, and actually while we're here, I'm going to add the logic to show you what it's going to look like when we actually do have an image URL for our community. So inside of here, I'm just going to add a ternary operator. So I'm going to add curly brackets, and I'm going to say community data.image URL. If this thing exists, let's show that image. And if it does not, let's show this icon. So this icon is acting as a fallback to the image. Now inside of here, we're going to say image, and this is coming from Chakra UI React. So if we save that, the icon's still being displayed because this does not exist. And we will come back and actually do something with this when we do have image URLs for our images, like we do for this baking one here. So underneath our ternary operator, let's add two more flex boxes. So an outer one and an inner one. The reason for all of these flex boxes will make sense as the visual parts start appearing. So many flex boxes. On the inner one, we're going to give a direction of column and a margin right of 6. And inside of here, this is where we're going to actually display the community name. And as always, text does not want to auto import from Chakra, so I'm just going to come manually add it myself. And inside of here, we can say community data.id, which is the community name. So that's showing up there. Okay, so let's make this heavy. So I'm going to say font weight is going to be 800. Let's make it a little larger as well. So I'm going to say font size is going to be equal to 16 point. Perfect. Underneath here, I'm going to add another text. So I'm just going to copy this downward. This is going to be slightly lighter, so 600, and it's going to be slightly smaller. So we're going to change this to 10. And this is going to say r/community ID. Exact same appearance on Reddit. And the color of this is going to be gray 400. Awesome, that's looking really good. And now this outer flex box is going to have a padding of 10 pixels, 16 pixels. Just like that, awesome. Now let's actually add the button that the user can click to join and leave the community. So that is going to be a sibling of this flex box here. So just underneath that, I'm actually going to create that button. So I'm going to import that from Chakra. So the text inside of this button is going to change depending if the user is in this community already. If they are not in the community, the button is going to prompt them to join. So it's going to say join. And if they are in the community, it is going to say joined. So this is where our community snippets are going to become useful. And remember earlier how I said we were going to add some global community state to our community's atom. Our community snippets are going to be part of that global state. Right now, we do not have it. So for now, I'm just going to create a variable called isJoined, and I'm going to set it equal to false, but this is going to eventually read from our community snippets to check if this current community is inside of our community snippets. So that's something we're going to cover very shortly, and it's going to tie into our global community state with our community's atom. But for now, we'll just leave it false. We're saying that they're not in the community, but at least now we have a variable to toggle this text. So inside of this ternary operator, we can use that isJoined variable, and we can say isJoined. If they're joined, show the text joined. If they are not joined, show the text join. Awesome. Now let's style this button a bit. The variant is also going to change depending on if they're in the community or not. So we can say is joined again. If they are joined, we're going to give it a variant of outline, and if they are not, we're going to give it a variant of solid. In addition to all of this, let's add a height of 30 pixels. Let's give it some right padding of 6, some left padding of 6, and we're going to give it an onClick as well, which right now is going to be empty, but this is going to be a function called onJoin that is actually going to join them or remove them from that community. So we're going to save that. So the reason I added that max width to this thing that currently has a red border is to prevent this thing from kind of infinitely stretching across the screen, because if they are on a large device size, it would look kind of weird if it was just spread across this entire header. So we sort of keep it compact like this, and our feed and the supporting components like over here are going to sort of have the same max width, and this matches exactly how Reddit has it, and it just prevents all these components from being like across the entire screen. So we just give it a max width to make it look good on all screen sizes. Let's remove that border now that that makes sense. All right, and now we have an actual visual representation of what our header is going to look like, minus this image URL thing, which we're going to add. But this is looking really good. And so all we have left to do in this component is to just implement this actual joining logic. But first, let's go work on the actual page content of the community page. All right, now let's actually talk about the content of this page beneath the header. So to start this section off, I want to go to our demo, and I just want to point out how pretty much every single page on reddit.com has the exact same layout. Let's open this up a bit to make this more clear, but we pretty much just have this parent component, and inside of that we have this left-hand side with kind of the feed, and this right-hand side with these other components. And the left-hand side kind of takes up, I don't know, about 60 to 70% of that width, and the right-hand side takes up about 30, and this is the same across every single page. So this is the home page. If I go to a community page, same thing, right? Just different components. But the overall governing layout is the exact same. Let's even look at the submit page. So pretty much the exact same thing. We've kind of seen a similar situation before, right? Remember how I was like, oh, we need the nav bar on all of our pages. And to solve that problem, we used a layout component and we just wrapped our app in our layout component and put our nav bar in there. But we can do the exact same thing elsewhere, right? It doesn't just apply to the global level of our app. And we can do that with the content of our pages because again, we have this left-hand content and this right-hand content with this repeated overall layout across every single page. And so what we're going to do is just create a simple page layout component and then wrap all of our pages in that component, and it's just going to automatically handle all of the styling for us, right? Like the widths and the responsiveness and all that stuff. And we don't have to repeatedly write the same CSS. So let's quickly do that in our app. So let's come back to here. So inside of our components folder and inside of layout, I'm going to create another component called PageContent because it sort of represents the layout of our page content for all of our pages. I'm going to use our classic snippet. I'm going to open up the demo just so we have a visual guide of what we're doing. So we can model this entire layout with just a few flex boxes. So I'm going to return pretty much the entire structure of this page content. What that's going to look like is we're going to use the flexbox from Chakra. So this is going to be the outermost parent container. Then inside of that, we're going to have the actual sort of content container. Then inside of here, we're going to have the left-hand side content and the right-hand side content. And we can represent each of those with just their own flexbox component, just like this. The outermost one is this kind of gray area, like the container of kind of everything. The next one, this one here, is going to be the parent container of both the left-hand side and the right-hand side. And then the two innermost ones represent the left-hand side and the right-hand side respectively. So a total of 4 containers, that's it. That represents this entire page layout. And it's going to represent our page layout for every one of our pages. Now we need to apply some additional styling to these things to just make them responsive and to give them the proper widths. But overall, this is it. This represents every single page layout. So for clarity, I'm just going to add a comment above this first flex box that says left-hand side. And for the second one, right-hand side. Okay, so now let's actually talk about what's going to go inside of both of these left-hand side and right-hand side flex components. Well, just like every other layout component, this is going to take in a prop called children. And if you recall, if we go back to our original layout component where we had our nav bar, children basically just represented our entire application because we wrapped our entire app in this layout component. So children is just a bunch of React components, right? And in this case, in layout.tsx, this was our entire app. Children is going to look a little bit different in here because we're going to pass in 2 children. We can pass in as many children as we want, but we're going to pass in 2 children because we need one for the left-hand side and one for the right-hand side. So our first child is going to be the stuff that goes inside of our left-hand side flex component, and the second child is going to be the stuff that goes inside the right-hand side flexbox component. And so this is kind of a weird concept at first, but bear with me. So if we come over to our index.tsx file, underneath our header is where we want to apply this layout component, right? We have our header, and then we have this left-hand side and right-hand side layout that we want to do. So underneath here is where we're going to actually put this. So we're going to say page content, bring that in from the other file. And this is where we're going to need to define our children that we're taking in for this page content layout. Just like in layout.tsx, the original one, children represented our entire app, right? If we go look at app.tsx, we can see that this component was the only child of this original layout, this one here. So in this case, we want 2 children because we, again, left-hand side, right-hand side. So let's come back to our index. And what we're going to do is instead of passing a single child like we were doing in our app.tsx file, we're going to pass 2 children. And we're going to represent both of those two children with React fragments, just like this. And we are totally allowed to do this. We are taking complete advantage of how React actually works from like a DOM perspective. So this first fragment is going to be child 1, and the second fragment is going to be child 2. But if it's more clear, you can just think of these as divs, right? That's really all they are. In this case, all we need them to be are fragments. And we're just putting them there to create this left-hand side, right-hand side structure. So again, child 1 on the left, child 2 on the right. So inside of child 1, for now, I'm just going to put a div that says left-hand side, and I'm going to do the exact same thing on the right-hand side. So we have this. Again, child 1, child 2. I'm repeating myself because this is kind of an abstract concept that I hope makes sense. Okay, so now inside of our page content file here, children is no longer just a single component. It is going to be an array of 2 components, right? In layout, it was just one thing. In this file, we have 2 because we have 2 fragments that we're passing here. What that means is that this children thing is going to be an array of both of those fragments. So if I log this, here is children. Let's look at what this looks like. So let's go back to our app and let's look in the console here. So see, it says here is children. Let me zoom in a bit, open this up, and we can see all that is in here is just 2 React fragments, right? React fragment, React fragment. And we could add 3 if we wanted to. We could add 100 if we wanted to. But there's 2 because we had 2 fragments, and that's all that these are. So now what we can do is take each of these 2 children and put them inside of our flex containers here. So our left-hand side is basically going to be children at index 0, the first element, and the right-hand side is going to be everything inside of children at index 1. To fix these TypeScript compiler errors, we can just do what we did before. We just have to make this 0 and 1 valid indexes of the children array. So what we can do is we can typecast it to be that. So we can say as key of type of children. Okay, and we're getting an error over here that's saying that children is possibly null or undefined. So to fix that, what we can do is we can just add a simple check, and this just checks to make sure that children actually exists and is a valid value. It is not null or undefined. Only then, let's render this. And we can do the exact same thing down here. So I'm just going to copy this entire thing, and then just change this to a 1. Just like that. Perfect. So now you can see left-hand side and right-hand side actually showed up on the screen here. And so we, of course, have to apply a few additional styling here to these flex boxes to make them have the widths and the responsiveness that we desire. But this is sort of the idea. And I think this is really cool. This is like this is a really cool way to take advantage of how React actually works and create custom page layouts. This children thing is a little bit weird at first, but just give it time, and I think it'll become a lot more clear when we actually start building out real left-hand side and right-hand side components like the feed and the about component and everything. But basically, the idea is that we can put whatever we want in here, right? I can put another div that's like, hello, and 10 more divs, whatever. It doesn't even matter. We can put as many components as we want in our left-hand side and as many as we want in our right-hand side. So depending on what page file we're working in, the actual components that go inside of both these 2 fragments will be different, but they are always just going to be the same structure because we only have 2 governing children. I hope that makes sense. I tried my best to explain it in the clearest way possible, but if that doesn't make sense, hopefully it does as we build more of these. And let's go to our page content and apply the simple styles that we need and responsiveness to these Flexbox containers, and hopefully it'll become more clear then. So I'm going to add borders to all of these to make it more clear what we're actually looking at. So I'm going to do 1 pixel solid red on the outermost. I'll do 1 pixel solid green on the actual content container, and I'll add 1 pixel solid blue on our left-hand side content, and then I will do 1 pixel solid orange on our right-hand side. Okay, now it's not very clear now because they're all sort of blobbed together, but let's keep going with this. So on our outermost container, we want to give this a justify of center. We kind of want to center everything, and we're going to give it a padding of 16 pixels on the top and bottom and 0 pixels on the right and left. Okay, now our content container, we're going to give this a width of 95%. Justify is going to be center as well because you kind of want to center the content, and we're going to give this a max width of 860 pixels. And if you recall, this is the same max width that we gave that component in our header. And this is so that they match up evenly and it looks really flush. So we're done with these 2. Let's come down to our left-hand side. So our left-hand side, we want to make all of the content inside of it direction column. And we want to give this a width. And this width is going to be responsive. At mobile screen sizes, we're going to make the width 100% because the right-hand side is not going to be visible on mobile screen sizes, so this thing can take up the entire width. And then on medium screen sizes, we're going to give it a width of 65 when it starts to share the screen with the right-hand side. Okay, things are becoming a bit more clear. And then we're going to make our margin right responsive as well. So at base screen sizes, 0, and at medium screen sizes, we're going to give it 6. Let's come down to our right-hand side. We can make the direction of this column as well. And we're going to make the display responsive. So at base on mobile, we are not going to have this thing visible. And then on medium screen sizes and up, we're going to make it display flex. Okay, and we're going to give it flex grow is equal to 1 just to make it take up the remaining width. Okay, so now hopefully this is becoming more clear and you can actually see this structure with your own eyes and kind of see how it works. And see how that max width matches up with that header component so it's nice and flush? That's why we did that. So this is looking really clean. And then on mobile, we don't have the right-hand side component. We only have the left. And so now what we've done is we have created a reusable page content layout component, and we can reuse this on every one of our pages and wrap the content in this layout component, and it's going to have the exact same look and feel, and we can have completely different components inside of our left-hand side and right-hand side due to these two children fragments we created. Okay, so I think I'm going to leave it there for part 3. We covered a ton in this video. We got to create communities. We got to see the ins and outs of Firebase. We got to learn about how to model data with a NoSQL database. We learned how to join communities and add sub-collections to our users and add custom properties to our users. We got to set up cloud functions and learn how to actually write cloud functions. We got to use database transactions. And now we've made really solid progress on our community page. And in the next part, we are going to actually build out the feed in our community pages and allow users to create posts within those communities. And it's going to be amazing. And I'm super excited. We're getting into the really, really fun stuff now. The post is like the funnest part of the project. So that is coming next. Thank you guys so much for watching. Please do let me know of any feedback you have in the comments. If you do enjoy this content, please give it a like and subscribe for more. I really, really appreciate it. Join my Discord. It is in the description. I really hope to see you in there. We have a decent amount of people in there now, so it's pretty cool. Come in there, chat with me. And I'm trying my hardest to get these parts out as fast as I can. I'm aiming for 1 to 3 days for each part, but there always seems to be obstacles that make it take slightly longer. So please bear with me as I get them out. I am getting slightly faster as I make more and more of these. Thank you so much, and I will see you in the next one.